Hey, and welcome to this lesson on polynomial long division. The objectives for this lesson are to divide polynomials and to factor a polynomial by dividing. Essential questions. What if you can't factor a polynomial using the methods we already know? So we just finished up on vertical motion, but before that we were talking a little bit about polynomials, and we were getting into how to factor them using completing the square, quadratic formula, things like that, which we definitely needed for vertical motion. Now we're going to get into other polynomials besides quadratics. So if we have a quadratic or a quadratic trinomial, we know how to factor that usually. Sometimes, though, we don't know how to factor it. If we had a quadratic trinomial, we would just use the quadratic formula. However, what if it's not a quadratic? What if it's a cubic or a quartic? So Salcon's going to take you through what we call polynomial long division. So go ahead, watch this video, and meet me back here when you're done.
In this video, we're going to learn to divide polynomials. And sometimes this is called algebraic long division. But you'll see what I'm talking about when we do a few examples. So let's say I just want to divide 2x plus 4 and divide it by 2. And we're not really changing the value. We're just changing how we're going to express the value. So we already know how to simplify this. We've done this in the past. We could divide the numerator and the denominator by 2. And then this would be equal to what? This would be equal to x plus 2. Let me write it this way. It would be equal to, if you divide this by 2, it becomes an x. You divide the 4 by 2, it becomes a 2. And if you divide the 2 by 2, you get a 1. So this is equal to x plus 2, which is pretty straightforward, I think. The other way is you could have factored a 2 out of here, and then those would have canceled out. But I'll also show you how to do it using algebraic long division, which is a bit of overkill for this problem. But I just want to show you that it's not fundamentally anything new. It's just a different way of doing things. But it's useful for more complicated problems. So you could have also written this as 2 goes into 2x plus 4 how many times? And you would perform this the same way you would do traditional long division. You'd say 2, you'd always start with the highest degree term. 2 goes into the highest degree term. You would ignore the 4. 2 goes into 2x how many times? Well, it goes into 2x x times. And you put the x in the x place. X times 2 is 2x. And just like traditional long division, you now subtract. So 2x plus 4 minus 2x is what? It's 4, right? And then 2 goes into 4 how many times? It goes into 2 times, a positive 2 times. Put that in the constants place. 2 times 2 is 4. You subtract, remainder 0. So this might seem overkill for what was probably a problem that you already knew how to do and do it in a few steps. But we're now going to see that this is a very generalizable process. You can do this really for any degree polynomial dividing into any other degree polynomial. Let me show you what I'm talking about. So let's say we wanted to divide x plus 1 into x squared plus 3x plus 3x plus 6. So what do we do here? So you look at the highest degree term here, which is an x, and you look at the highest degree term here, which is an x squared. So you can ignore everything else, and that really simplifies the process. And you say x goes into x squared how many times? Well, x squared divided by x is just x, right? X goes into x squared x times, and you put it in the x place. This is the x place right here, or the x to the first power place. So x times x plus 1 is what? X times x is x squared. X times 1 is x. So it's x squared plus x. And just like we did over here, we now subtract. And what do we get? X squared plus 3x plus 6 minus x squared. Let me be very careful. This is minus x squared plus x. Don't want to make sure that negative sign only, it applies to this whole thing. So x squared minus x squared, those cancel out. 3x, this is going to be a minus x. Let me put that sign there. So this is minus x squared minus x, just to be clear. We're subtracting the whole thing. 3x minus x is 2x. And then you bring down the 6, or 6 minus 0 is nothing. So 2x plus 6. Now you look at the highest degree term, an x and a 2x. How many times does x go into 2x? Well, it goes into it 2 times. 2 times x is 2x. 2 times 1, 2 times 1 is 2. 2 times 1 is 2. So we get 2 times x plus 1 is 2x plus 2. But we're going to want to subtract this from this up here. So we're going to subtract it. Instead of writing 2x plus 2, we could just write negative 2x minus 2 and then add them. These guys cancel out. 6 minus 2 is 4. And how many times does x go into 4? Well, we could just say that 0 times, or we could say that 4 is the remainder. 4 is the remainder. So if we were to rewrite, if we wanted to rewrite x squared plus 3x plus 6 over x plus 1. Notice this is the same thing as x squared plus 3x plus 6 divided by x plus 1. This thing divided by this. We can now say that this is equal to x plus 2. It is equal to x plus 2 plus the remainder divided by x plus 1 plus 4 over x plus 1. This right here and this right here are equivalent. And if you wanted to check that, if you wanted to go from this back to that, what you could do is multiply this by, you could multiply it by x plus 1 over x plus 1 and then add the 2. So this is the same thing as x plus 2. And I'm just going to multiply that times x plus 1 over x plus 1, right? That's just multiplying it by 1. And then to that, add 4 over x plus 1. I did that so I have the same common denominator. And when you perform this addition right here, when you multiply these two binomials and then add the 4 up here, you should get x squared plus 3x plus 6. Let's do another one of these. They're kind of fun. So let's say that we want to simplify x squared plus 5x plus 4 over x plus 4. So once again, we can do our algebraic long division. We can divide x plus 4 into x squared plus 5x plus 4. And once again, same exact process. Look at the highest degree terms. In both of them, x goes into x squared how many times? It goes into it x times. Put in the x place. This is our x place right here. X times x is x squared. X times 4 is 4x. And then, of course, we're going to want to subtract these from there. So let me just put a negative sign there. And then these cancel out. 5x minus 4x is x. 4 minus 0 is plus 4. X plus 4, and you could even see this coming. You could say x plus 4 goes into x plus 4, obviously one time. Or you could just look at, if you were not looking at the constant terms, you would completely just say, well, x goes into x how many times? Well, one time. Plus 1. 1 times x is x. 1 times 4 is 4. We're going to subtract them from up here. So it cancels out. So we have no remainder. So this right here simplifies to, this is equal to x plus 1. And there's other ways you could have done this. We could have tried to factor this numerator, right? X squared plus 5x plus 4 over x plus 4. This is the same thing as what? We could have factored this numerator as x plus 4 times x plus 1. 4 times 1 is 4. 4 plus 1 is 5. All of that over x plus 4. That cancels out, and you're left just with x plus 1. Either way would have worked. But the algebraic long division will always work, even if it's not a perfect, if you can't cancel out factors like that. Even if you did have a remainder. In this situation, you didn't. So this was equal to x plus 1. Let's do another one of these. Let's do another one of these, just to make sure that you really have, because this is actually a very, very useful skill to have in your toolkit. So let's say we have x squared. We have, let's say we had, let me just change it up. Let's say we had 2 2x squared. I could really make these numbers up on the fly. 2x squared minus 20x plus 12 divided by, actually, let's make it really interesting. Just to show you that it'll always work. I want to go above quadratic. So let's say we have 3x to the third minus 2x squared plus 7x minus 4, and we want to divide that. We want to divide that by x squared plus 1. I just made this up. But we can just do the algebraic long division to figure out what this is going to be, or what this is, if we simplify it, what it'll be. X squared plus 1 divided into this thing up here. 3x to the third minus 2x squared plus 7x minus 4. Once again, look at the highest degree term. X squared goes into 3x to the third how many times? Well, it's going to go into it 3x times, right? You multiply 3x times this, you get 3x to the third. So it's going to go into it 3x times. So you have to write the 3x over here in the x term. So it's going to go into it 3x times, just like that. Now let's multiply. 3x times x squared is 3x to the third, right? 3x times x squared plus 3x times 1. So we have a 3x. Over here, I'm making sure to put it in the x place. And we're going to want to subtract them. And what do we have? What do we have when we do that? These cancel out. We have a minus 2x squared. And then 7x minus, because I just subtracted 0 from there, 7x minus 3x is plus 4x. And we have a minus 4. Once again, look at the highest degree term. X squared and a negative 2x squared. So x squared goes into negative 2x squared, negative 2 times. Negative 2. Put it in the constants place. Negative 2 times x squared is negative 2x squared. Negative 2 times 1 is negative 2. Negative 2. Now, we're going to want to subtract these from there. So let's multiply them by negative 1, or those become a positive. These two guys cancel out. 4x minus 0 is 4x minus, let me switch colors. 4x minus 0 is 4x. Negative 4 minus negative 2, or negative 4 plus 2, is equal to negative 2. And then x squared now has a higher degree than 4x, and the highest degree here. So we view this as the remainder. We view this as the remainder. So this expression, we could rewrite it as being equal to 3x minus 2. That's the 3x minus 2 plus our remainder, 4x minus 2. All of that over x squared plus 1. X squared plus 1. Hopefully you found that as fun as I did.
All right, well, welcome back. So you should have learned how to divide polynomials, the same way you would divide whole numbers or integers. And you should have seen that you could either have a remainder of some number or have a remainder of 0, or not have a remainder at all. The interesting thing about having a 0 remainder is that it tells us that what we're dividing by is a factor of what we divided. So for example, x squared plus 5x plus 4 actually factors into x plus 4. And when I factor that out, I'm going to get a quotient, or x plus 1. We should already know this because we can factor this quadratic trinomial. What adds to 5 and multiplies to 4? Well, positive 4 and positive 1. It's the same as saying that I'm going to divide 10 by 5. Well, 5 goes into 2. Or sorry, 5 goes into 10 twice. Sorry, 2. 5 times 2 is 10. If I subtract that, I'll get a remainder of 0. Well, that tells me that 5 and 2 are factors of 10. So, if I'm asked how to factor something and I can't factor it, my first step could be to divide it. Well, I'm shown here that x plus 1 is a factor. So what I'm going to do is I'm going to divide this polynomial by x plus 1. So x plus 1 divided by x to the third plus 2x squared minus 5x minus 6. So if I start to divide now, what times x will give me x cubed? Well, x squared. X squared times x is x cubed. X squared times 1 is x squared. If I subtract that through, I'm going to get 0 plus 2x squared minus 1x squared is 1x squared. And then I'm going to bring down the rest of the equation. Really, I'm just adding or subtracting 0 from both of those, so that's why I can just bring them down. Then, what times x squared will give me, or x times x, what will give me x squared? That's what I'm trying to say, and that's x, so plus x. X times x is x squared minus x minus 6. Oops, sorry, not minus 6. X squared minus x squared is going to give me 0. Negative 5x minus x is actually going to give me negative 6x. And then I am going to bring down that negative 6. And one last time, what times x is going to give me negative 6x? And that's going to be a negative 6. X times negative 6 is going to be negative 6x minus 6. And that's going to give me my remainder of 0. So, indeed, x plus 1 is a factor. So if I factor this polynomial, x plus 1, and when I factor something out, I'm really dividing that something. So if I have a 6 and I'm going to factor out a 2, what I'm really doing is I'm dividing it by 2. So I'm taking the 2 out. Then I'm dividing it by 2 to see what's left. And what's left is a 3. 2 and 3 are both factors of 6. So I'm going to factor out x plus 1. And so what's left is this polynomial, but divided by x plus 1. And what is that? Well, we just found that to be x squared plus x minus 6. So x squared plus x minus 6. From there, are we done factoring? Well, no, actually, this quadratic can stay. So we're going to divide one more time. Just kidding. We don't have to. We could divide, and that would be totally acceptable. We would get our answer. But this is a quadratic trinomial. So we can look at it and say what multiplies to negative 6 but adds to 1. X minus 3 and x plus 2. Now this cubic function, this cubic polynomial, is now factored into its 3 factors. X plus 1, x minus 3, and x plus 2. And that would be your fully factored polynomial. Thanks for watching. That's all I have for this lesson. Be sure to go back through. If you still don't understand anything, go back through, really take some good notes. Go ahead and try to practice on your homework assignment. And be sure to meet me in live class where we can go over this a little more in depth.